As an example of angular and linear velocity, let's think about an example. So if a wheel of radius 10 inches rotates at 3 revolutions per minute, what is its linear speed? So another way to think about linear speed is you can imagine this wheel. How fast would it roll? So you have a wheel that's rotating, and you can imagine how fast would it roll along the street. Well, let's see what we're told. We're told that the radius of the wheel is 10 inches. And we know that it's revolving at 3 revolutions per minute. So let's, there are lots of formulas for these types of things, but I like to just sort of reason it out and use my unit conversions to figure out what I need to determine. So in this case, I'm told that I have 3 revolutions per minute, and I want to arrive at a linear speed, so some sort of unit of distance per unit of time. So I need to basically convert away this revolutions, figure out how to convert revolutions into a linear distance. So the thing to think about is, well, what is one revolution? One revolution is a complete turn of the circle, which we know that the circumference of a circle is 2 pi r. And since we're told that the radius is 10 inches, we know that the one revolution is 2 pi times 10 inches. So that's what one revolution is in terms of a linear distance. That's how far the wheel goes when it makes one revolution. So we can use this conversion factor, or we can use this equation to make a conversion factor that will allow us to convert this into a linear distance. So all we need to do is think about revolution. We want to cancel out revolution, so we're going to put one revolution in the denominator, and we know that one revolution is equal to 2 pi times 10 inches, so that's 20 pi inches. So 20 pi inches goes in the numerator here, and we can now cancel revolutions. And so that leaves us with 60 pi, 3 times 20, so 60 pi inches per minute. So that is now a linear speed, right? We have a distance in inches per minute. But usually, feet per minute might make more sense. So let's just see how, if we wanted to convert this into feet per minute, how we would do that. So 60 pi inches per minute. If we want to convert now to feet, well, we want to cancel inches. And there's 12 inches in 1 foot. So this will allow us to cancel the inches and leave us with feet per minute. And the 12 and the 60 cancel to leave us with 5 pi feet per minute. And that's approximately 15.7 feet per minute. So that's the linear speed of the wheel. There's another example. If a wheel of radius 12 inches rotates at 6 revolutions per second, what is its linear speed? So, again, we have 6 revolutions per second. That's our starting point. And we want to arrive at some sort of linear speed, so maybe feet per second or something like that. So let's just remind ourselves what we need to convert away. We need to cancel a revolution. So let's figure out what a revolution is. Well, one revolution is a full circumference of the circle, which has radius 12 inches. So 2 pi times 12 inches. So that's 24 pi inches. That is one revolution. So that's what we can use in a conversion factor, or unit conversion factor, to cancel revolutions. We'll put 1 revolution in the denominator and 24 pi inches in the numerator. And you know, we can now multiply this out. This turns out to be 144 pi inches per second, right? The revolutions have canceled in inches per second. And just for the sake of argument, because that's inches is a hard thing for us to think about, let's convert this to feet per second. So if we want to do that, we'll use a factor of 12 inches equal to 1 foot, inches in the denominator to cancel. So the inches will cancel, and we're left with, well, the 12 and the 144 cancel to leave us with 12 pi. So we get 12 pi feet per second. And that comes out to be approximately 37.7 feet per second. Now, if a wheel of radius 14 inches has a linear speed of 20 miles per hour, what is its speed in revolutions per minute? So let's think about this. If we're told that our linear speed is 20 miles per hour, but we want to know revolutions per minute, we're going to have to do two conversions. We're going to have to convert miles into revolutions and hours into minutes. So there's going to be a lot of conversion factors going on here. So let's start by getting miles into inches, because that's going to help us convert between inches and revolutions. So we'll start by multiplying by 5280 feet per 1 mile. So this is just a fact that you would have to look up if you didn't know it. There are 5280 feet in 1 mile. So that'll convert away the miles. Now we want to get to inches, so we'll do 12 inches per 1 foot. Remember, we want the unit in the denominator that we're trying to cancel, so feet will cancel here. So now we've converted to inches. Once we do this, the miles will cancel, the feet will cancel, and now we're in inches. But we're not quite done. We need to get to revolutions. So think about what's 1 revolution. Well, 1 revolution will be 2 pi times the radius, right? Let me just do that. It'll be over here. So 1 revolution is 2 pi r, which is 2 pi times 14 inches. So that's what 1 revolution is. So we'll use that to convert away these inches. We want to cancel the inches, so we're going to have a factor of 1 revolution divided by 2 pi times 14 inches, which is 28 pi inches. Okay, so now the inches will cancel, and so now we have revolutions per hour. But remember, we want revolutions per minute. So now, well, let's just sort of collect what we have here. Well, let's just keep going. So what other conversion factors do we need? Well, we need to get hours to minutes. Well, actually, we can fit it in here. We just need one more conversion factor, which is just 60 minutes per 1 hour. Oh, but notice I made a slight mistake here. I actually want to cancel the hours and be left with minutes in the denominator. So that's not actually the factor I want. I want to have 1 hour divided by 60 minutes. So that was not the right factor. But 1 hour divided by 60 minutes, that will cancel the hours and leave me with minutes in the denominator. So this is an easy mistake to make, but if you just remember which way you want your units to cancel, you'll get it right, and you'll catch any errors like that. Okay, so the hours will cancel, and I'll have minutes in the denominator, and I'll have revolutions in the numerator, which is what I want, revolutions per minute. So now I just need to multiply all of this out. And when I do that, this comes out to be about 240 revolutions per minute. So that's an example of converting from linear speed into angular speed, revolutions per minute. Okay, so now we're told that a wheel of radius 12 inches has a linear speed of 55 miles per hour, so it's cruising, and we want to know what the wheel speed is in revolutions per second. So let's just set this up with what we start with. We start with a linear speed of 55 miles per hour, and think about where we want to arrive at. We want to get to revolutions per second. So we're going to need to convert our miles into revolutions and then our hours into seconds. So let's start with the miles. So miles, we'll start by converting into feet. So 5,280 feet per 1 mile. So that'll cancel our miles. Now we're in feet, but it'll be better to be in inches because that's what our radius is given in. So we'll take 12 inches per 1 foot. Again, we want the foot in the denominator to cancel with the foot in the numerator. So now we've converted to inches, but we need it in revolutions. So let's remind ourselves, what's 1 revolution? Well, 1 revolution is going to be 2 pi r, right? That's 1 time around the circle. So 1 revolution is 2 pi times the radius, which is 12 inches. Okay, so this will cancel the inches, and now we have revolutions, but we have revolutions per hour. We want revolutions per second. So now we want to get the hours into seconds, and now we need to cancel the hour in the denominator. So we'll put 1 hour in the numerator is 60 minutes. In the denominator, that'll cancel the hour and the hour. And then last, we just need 60 seconds in the denominator for every 1 minute in the numerator. And again, we did that because we wanted to cancel the minute from the denominator here and leave us with seconds in the denominator, because that's our final goal, was revolutions per second. Okay, so now we have all the conversion factors we need, and if you multiply all of this out and simplify, you get that this is approximately 13 revolutions per second.